A little back and forth on the last year and the big thing that happened, which is the release of Liquidsoap2. We'll look back at what we did and then talk about what we have for plans in the future. And maybe if we have time, we would love to open up for discussions and get some feedback from y'all. So let's take a look back first. And yeah, so the three major things that happened last year was the release of 2.0 ongoing bug fix stream. But yeah, it was a major rewrite, and the most important thing, the two most important things was the FFmpeg integration that I'll present and talk about first, but also the language features that are mostly the work of Samuel, bringing back some of the theoretical computer science stuff into the existing applicable languages, and it's much appreciated, and I'll go over that as well. And eventually what we did is we released a book because, and I'll talk about it, we understand that not a lot of people who are interested in streaming are necessarily software engineers. And so we wanted to help lifting and getting people the right tools that they can have to learn and get more comfortable using the software and the language itself. So first, we'll talk about the FFmpeg integration. It all started when we started having more and more need for audio formats. I think when we did HLS, we realized that the requirement for HLS were completely out of what we currently could do with just straight up in-house binding of AAC libraries and all that, because it was pretty intricate work on the container, the MPEG TS container. And so we started integrating FFmpeg more and more. And what happened is that we realized that it's always important when you do computer work, and I mean in life in general, to know what people do, and sometimes people do better than you. And FFmpeg has been around for 20 years. It has a worldwide community of expert developers. Some of them are paid by hardware companies, and they can optimize at the hardware level or the assembly level pretty intricate encoding routine or muxers, demuxers. And so, yeah, they do that very well. And frankly, their APIs are excellent. It's been a pleasure to work with it. It's very well defined. It's very clear. And they are very much a extensive, all-encompassing toolbox. They can work at the codec level, the mixers. They have support for input-output protocols, particularly like stuff that we were struggling to implement one by one on our end, like RTMP and that kind of stuff. They also support devices, although from our own perspective, it's a little bit better to do it ourselves on that level. And they have a super good API for filters that we've implemented that allows us to get a lot of manipulation options and operators that can, flip a video, change some audio, etc. And again, we're not expert on audio processing and video processing, so we're really tapping into a huge amount of resource here. And so, yeah, that was the idea. Now it's the de facto reference implementation. Everybody wants to contribute to FFmpeg when there is a new codec, when there is a new architecture to support. And so it makes sense to do our best to integrate as much as possible, because it immediately gives us all the range of supported things that FFmpeg has. So that's our vision here. Is the question becomes, what do we provide that FFmpeg doesn't provide? And so what we are, and that's, I think, really what is the added value of Liquidsoap, is we're a programming language. And that means that we provide specialized operators and variables. We have programming abstraction, like functions abstracted as structures. We have static typing, which for a lot of people might be frustrating, but actually helps the user a lot. And that is tools that are much more advanced, allows for much more advanced thing than a programming language. And so our vision is to have a tight integration with the FFmpeg APIs, and whatever you can do with the command line, we should also be able to do. And if it doesn't work, we should investigate and be able to support it. We want support for all codec, mixers, protocols that FFmpeg has, but we want to provide the language flexibility. And so here's an But it's not only that, is that FFmpeg is still a C API, and we're like more flexible than that. So typically for HLS, we're not using the FFmpeg output for HLS. And the reason is we want a lot more flexibility. So typically segment callback. So when a segment is ready, we can call a language function that allows you to do whatever you see fit with it. Typically, you could upload it to S3 and a cloud system so that it's available with CDN. You can define the segment names based on whatever variables you want. And all these things provide much more flexibility that the command line FFmpeg utility cannot really do. That's where we also provide more stuff. We have SRT input-output, we have device support, all that is more extended than FFmpeg. So we also have more to offer here. So here's an example of what we can do with the programming language. So FFmpeg, as I was telling you, has filters, and that's an example of a complex filter. I found it online on a Medium article about how to do FFmpeg filters, and yeah, that's the graph of it. It takes an MKV input video, it splits it into video and audio separately. That is, I forgot, I looked at it, it's a specific filter, I think, for de-interlacing. Then it splits it in three. One end does thumbnails, another end is scaled down and flipped, and gets an audio merged back. It gets an output merged back with the audio, smaller scale and flipped. I don't know why, but that's what they want to do. Another one is scaled to this and gets another output. It's actually not even a very complex filter if you think about it, but already you see that it's like pretty hard to read, in my opinion. They have this syntax that's like you name your input, you reuse them here, and I mean, I find that. And also, you want to get bigger and bigger filters, it gets even more complicated. So here's our implementation of it, and please don't. I've just wrote the code. I haven't tested it, but I suggest it probably works. So that's our graph, and that's the implementation in Liquidsoap. Oh yeah. First, sorry, I forgot. First, we're gonna remove the thumbnails because we don't really do thumbnails. We do video output mostly. So that part I didn't translate. But here's the code. And so we start by getting the audio and video output. That's pretty much what happens in the first arrow here. And then we're gonna step by step replicate exactly what goes on in the filter originally. So the first one is this format filter. I think it converts to, it makes sure that the input is always in UV, as it could be RGB, although in Liquidsoap it's always UV, so you could probably remove this one. And then on and on, you know, we're gonna apply the filter, we're gonna apply the split. The split has a little bit trick that I wanted to talk about briefly, is that it returns audio and video array, and you might say, well, that's weird because you're splitting a video, so why would you return audio? Well, that's a typical example of, we don't know from the FFmpeg filter API that this thing only returns video. We just know that it's a dynamic filter or dynamic output. And so we have to be generic as much as possible. So we always return an array of audio and video, and this one is empty. So that's what's happening. And then we get the input 1, input 2, we apply the scale, we flip, we resample the audio, and we merge it back. So here we get back. So, you know, the thing that's interesting is that this is a Liquidsoap source, and this is an abstract audio and video FFmpeg source. So eventually we convert back to the FFmpeg world and then back into the Liquidsoap world here. And then eventually we remerge this audio with the video and we return it in a nice structured record. That's one of the new features of the language, and that gives us our filter. And so I think it's pretty much more readable, more flexible. We could use variables, we could use a lot of things inside this that you would not be able to do easily on the command line. If we get time, we could talk about why this is like that. The reason is that the FFmpeg API works with an abstract thing that's called a graph. And you need to configure your own graph before you can launch it, and it returns errors if you made errors on your filter. And so that's the way we have adapted it in the programming language. We give you a little callback that receives that graph, does all the setup and returns the value. And when after that function is applied, we say, hey, FFmpeg, launch the graph here with everything that has been configured and return an error if there's a problem or not. That's what's being done here. So that's an example of us providing a really advanced thing. I'm going to move forward and try to be in time here. The other thing we've added is, The possibility to have an output without re-encoding, that's much more easy. Basically, you specify this FFmpeg encoder, and you say, I want to copy audio and copy video. And you use it just like any other encoder in the language. But what we're going to do is we're going to go backward and say, OK, I want audio copy here. Hey, fallback, make sure that the source that you have is a copy, FFmpeg copy. And he's going to go to source and static and say, hey, source, decode files using the FFmpeg decoder, but don't decode the raw data. Just give us encoded data. Same thing with the single, and then everything's going to flow from the source down to the output without decoding audio and video and saving a lot of CPU. That's a very cool feature that has been asked for a long time because we've been doing that for a long time. So we didn't think it was possible, and then FFmpeg made it possible. It's great. Keep going to the second part of this presentation. I hope the pace is okay with you. We got to try to be in time here. We're going to talk about the language features. One of our philosophy for the language is that simple things should be simple, and then our follow-up with complex things should be possible. And so what we're trying to do here is that we are trying to work with the fact that not all people interested in streaming are programmers. That programming language can and should help, but they should be simple for the simple things. Complexity should, in theory, arise only when needed, although we'll see that sometimes, unfortunately, that happens, that things get complicated by virtue of sometimes you have to. But we are aware of user request features. We try to fix bugs, and we have limited resources because it's only, at the moment, Sam and I and a couple of other contributors. But really what I want to say here is that we understand that most people coming to this want to stream. They don't want to be programmers. But what we want is to provide tools that help them do their stream and get them the power of what we can offer while helping people get more comfortable with it. So that's why one of the things we did is write the Liquidsoap book. We really thought that it would help giving a path to learn from what is a stream, what are the technologies available, how do I do this, what can I learn to, what is a programming language, even down to like, basic thing, what is a function, what do you mean by a callback, and we want you all to know that we always very much in tune to these things, and we want to be there, but with limited resources. So whenever possible, here. So here's an example that we've done in the actually the bug fix release 2.0.2 of things to help users. That was a real problem. We say we have typing issues, and one message that I want to say is typing issues are very annoying when you write your code, but I'll tell you, it really helps long term because it gives you a lot of frustration. But once the typer passes it, you guarantee certain things that are not going to blow up in production. And that really is important. People who work with JavaScript probably know the pain. That's why TypeScript is becoming more and more popular. But anyways, a lot of frustration was like, hey, line something, character such and such, type error, this value as type, it should be that. But it was like, oh, I have to go back to my code. I have to open the file. I have to look where it's at. I'm not sure exactly what our characters 44 to 51. And so what we've added is a little syntax highlighting that Sam's work here too, that says, hey, this is where you need to change the type. And then that's becoming pretty clear. It actually comes from me implementing that filter earlier when the sample rate was an integer, and I didn't realize that. And so right away, you're like, oh, okay, I can go back to my file here, look at this line and change this. Makes sense. And the thing that's really cool for us, frankly, and that's something that we're really proud and happy, is that there is a community behind it. And that came from a feature request. So that's another message. We really appreciate reports, whether they're bugs or feature requests. We ask you all to be patient because we try our best to get to it one by one, but we will. And sometimes you all can think of things that we haven't thought. And typically that's an example where that was a feature request. And we're like, yep, that kind of makes sense. We should probably have that. And then now we have it. So thank you for suggesting it. Now, I was saying, to keep going with that, we try to get people the tools they need to learn. So we have an online documentation that is generated from the binary. So it should mostly, that part, the API doc should mostly be in sync at all times. Sometimes the other articles, because they're handwritten, they can get a little bit drifted away from the actual code. But this part is always going to be up to date, as long as the CI pushes the latest version. But the other thing that we want to highlight that perhaps not everybody is aware of is that you can always request the detail about an operator through the command line. You run your binary Liquidsoap, it says -h request.q, and it's going to return this. First, a little description of the function, a type here, which, you know, might be confusing at first, but you get used to it. And it basically tells you all the parameters, the types that they have, and the type and the data, the things that the function return. The parameters are documented one by one, so they should tell you what they are for and what we can use them for. And eventually, this section is called the methods, and it's one of the brand new feature of Liquidsoap2 is that we have added methods to any variable. So the source now I can take, it's like a little object in a functional object-oriented programming. So that function request.q returns a source, and on that source variables, you can call certain methods that are specific to it. So you can add a new request. You can say, what is your current request? How long do you have in the current track? How long have you played in the current track, etc., etc. There's a long list. I've cut it down. And that's probably the most significant feature of the 2.0 language. It has a lot of added flexibility and added power to the language, which I'm going to get about. It also, unfortunately, raised a little bit of complexity that I'm also going to present in the next section. So here's complex things should be possible, and that's a perfect example. That's from our internal library. So I'm not expecting you all to write code like that. Especially this args-off, it basically allows us to replicate the arguments without having to know exactly what are all the arguments, and we override the request. So what does that do? It takes the request.dynamic operator function, creation function, and adds a telnet function when you create that source. The function is called flush and skip, and basically it means that you're gonna empty the queue of the function and then skip the current song. It's a functionality that a lot of users kind of want a lot of the time. It's very useful. But what you see here is that it really is the trajectory that we're trying to go, because before that, all the telnet functions were in the core OCaml code, and they were hard-coded. You could not really modify them. And also, you could not really set things from inside the language. People who've been using Liquidsoap for a while might be familiar with the fact that before, to be able to do that, you had to call server.execute and execute a telnet command within the script. It was completely abstract meta programming. And so this is much more useful, because now you can, if you're inside your script, you can just go set queue with an empty list, or you can skip. It's a very natural programming aspect, but you can still do telnet functions, and you can program them from the library instead of having them hard-coded. And that's also another direction for us, which is we are trying to move more and more things to the Liquidsoap library that's written in the scripting language, and minimize our core so that what we have to support in the core is minimum. So that means less bugs, more flexibility. Eventually, we even hope we can do separate release for the core and for the library, so we can do a lot of bug fixing without having to reinstall Liquidsoap or do a full release. So that's an example. But sometimes complexity is inevitable, and I'm going to give an example that a lot of people here, some people might have seen happen recently. So that's a little function. It says, let's say that I want always to put a fallback that's a playlist on all my sources in my script, whatever, it's a playlist. And so that's does just that. It takes a source A and returns a fallback with that playlist here. Unfortunately, what goes on is that, as I told you, all the playlist has a new method attached to it. And those methods are here when you look at the type of the function. By the way, that's another thing you can do. You can always do the -h on functions of your own script. You load the script and you type -h, and it's going to return the documentation. Can help you like figure out the type of the function you're writing. And what we're seeing here is that it takes as input a source with all these methods here. Particularly, what do we see? Add, queue, fetch, reload. Those are all playlist specific methods. So what's basically happening is that when we're trying to find the type of this thing, we say, oh, we have a list, and that list has a playlist and another source. Oh, that playlist has all this method attached to it. Oh, well, I guess the other source should also have the same method. to be consistent, because in a list you need the same type. They need to be all of the same integer, float, or playlist source with this type of method. And so the typer is going to say, if you return a source if you have a playlist in the list of source, the other one should be the same type, and boom, it expects all these methods attached to it. And then that's where you run into these things where you say, oh, I want to put a playlist fallback on my input.harbor, the little source that can receive IceCast's source client. And then that's what's going to happen. Boom. Unfortunately, that's the nice syntax highlighting though. There's no method length. And that's because input.harbor is not a playlist, so it doesn't have the same list of methods as playlist. This is unfortunate, and Sam might want to talk about it. He's working very hard to try to fix that, but on a theoretical level, it's complex. Let's just say it this way. He's been reading a couple of academic paper, and I think he's done 3 or 4 implementation. But still, we want to make it like so that if we implement something that makes this work, the error that's going to return is readable. And at the moment, we just haven't found a way to make it so that when it says, oh, you have a type error, it's not going to return something that's completely crazy. So the only thing we have at the moment, unfortunately, is that we have this little type annotation here that we use through the code, and we're going to try to tell people about it more and more. And it basically says, oh, in this playlist fallback, that source here, playlist, forget about the methods. Okay, we don't care that it's a playlist that has unqueue, whatever specific playlist method. All we care is that it's a source. And that's true, because the fallback doesn't care about the method of playlist, it just wants a source. So this is going to tell the type checker to forget about every specific method on the playlist and just consider it as a source with the method. And then it's going to pass and make it work. Boom. See, now the type is a simple type, take a source, return the source, no method attached to it, boom. I'm getting to the end of that presentation. I hope the space was good. Try to save a little bit of space for question here, but what do we have in store for the future? We want to make things even more simple when we can. This is from 2.1 that we're currently working on. It might not come out soon because, as I'll tell later, we have some important rewrite we want to do, but this is in at the moment. If anybody has ever tried to do JSON parsing in 2.0 and before, let's just say that I'm not very happy about how it works. It's pretty intricate and very difficult to do. This is how we wrote it. Basically, you declare a little type here, and it informs the parser that we're going to parse a JSON object. It's going to have a name entry that's a string, a version entry that's a string, a script that is a sub-object with a test that's a string, and then we're going to parse that. Also, what we're doing here is a little deconstruction. So you don't even need to deconstruct manually. With this single call, you're going to read the content of package.json, parse it according to the shape that's here, and then you're going to receive a variable that's version, name, script, test, and all that will be according to the types that we have. And that should make the script much more simple. And that's the direction we're trying to go with everything in general. Yeah, we understand the pain, and we're there, Richard. But the reason that 2.1 is going to take some time is that we want to continue moving functionalities out of the OCaml core as much as we can, and our library is growing and growing. Sam was commenting that every time you change the type system at this point, there's going to be something in the library that blows up if the change is not correct. So that helps a lot. As I said, we're going to try to do maybe eventually be able to release different versions of the library independently from the core. We want to improve type checker whenever possible, so typical situations like the one I explained. But the thing that's ongoing that's really important is we want to not be afraid to do some refactorization, modernization. Liquidsoap is a project that's over a decade old, and some of the stuff we did 10 years ago, we look at it now, we're like, we could probably do better. One of the things that we have in store right now that's in flight and being changed is the track marks and breaks. I won't get into too much details, but in our definition of internal frame that we use for the streaming loop, we kind of use the same abstraction for what is a track mark and what is a partial fill of the frame. It's called the breaks, and it creates a lot of confusion in the semantics of the operators. And that's the source of a lot of bugs where things are not triggered at the right time, or the track is not. It's a lot of bugs all the time, and so we want to change that. We want to separate the notion of track marks and partial fill of a frame. We want to also work with more immutable content, so we don't copy as much. I was actually working on it just today. That's one of these things that are not efficient at the moment. We do too much content copy, so we're working on that. And eventually, we want to rewrite the streaming model. There's a lot of code complexity that we could reduce, make the streaming loop more simple. We want to rewrite the clocks. If anybody has tried clocks, it's still a confusing notion. We want to make it simple, and particularly what we want is also prepare for the multi-core OKML. So OKML is going to come up soon with the support for pushing code into different core without having to have mutexes and blocking operations. And potentially we could have a situation where if you have a whole streaming system, we can spread over the different cores of your CPU, file decoding, ads, all the different operations could be spread over, and it would optimize the computation of a stream. And that's about all for this presentation. Thanks for your time. I think we have a little time for questions. And as I was saying, particularly we're looking for feedback. What do you guys think we could do? Yeah, anything that y'all can want to talk about. We have a couple of minutes left. How about like for LTB? What do you mean, Dreamer? Do you mean like receiving an RTMP stream? Yeah, I think we have an input.rtmp at the moment that is using FFmpeg. Sam has worked our core implementation, but for now we're using FFmpeg for that, and I think it's working. VU meters. Ernesto, I think we have an operator that returns that as methods attached to sources, if I remember well. Sam has worked on that. But we could probably do a better job at explaining how to use it for sure. Yeah, Gio, OSC interactions, that's also Sam territory. I think he's done a bunch of that. As well, it's probably something that the documentation could be enhanced. Also, guys, I think it's possible to open microphones and talk for real, if I'm correct.
Yeah, I tried it. Hi.
Nice.
Yeah, I wanted to say thank you for the JSON capabilities. It's actually quite better this way, and you felt OPAIN because probably you you dealt with it as well. So, and the new languages, yeah, the modules and stuff are getting some. It takes some time to get used to them, but it's really great. So feedback, you have it. It's good. It's a good way.
Thank you. Appreciate you. All right, I think we're on time. Sam, do you want to? We can follow up with more conversation here in the chat or in the. Oh, I wanted to say, sorry, one last thing. We're trying to move eventually to Discord, and the reason is Slack doesn't store messages unless you pay for it. And so we're going to try to prepare a bridge and eventually move the chat and community to Discord. Oh, I see. Well, that's another thing we can discuss. Anyway, I'm leaving the stage back to Sam and the next presentators. Thank you for your time, y'all.